Okay, so we're going to get started today. Unfortunately, recording from the other class did not save correctly. So we're going to try again right now with this recording. So as you see here, we have these directly from your notes. If you do not have your notes, ask Mr. Jarvis if he can get you some. So we have these three transformations. We have translation, reflection, and rotation. If you remember from last week, our fourth transformation, because we talked about four, was dilation. The thing that dilation did was that it grew, it changed sizes. But these three, the one reason these three are different is that because they stay the same. They do not dilate, they do not change size like the others. They do not change size or anything. So we call these congruent transformations. So three congruent transformations of translation, reflection, and rotation. So we call them congruent because the shape stays the same. And congruence is a really important math word that we like to use that will show up later on in geometry. So whenever we say the word congruent, we always want to remember that means the same. Everything's going to stay the same. So as we translate our shape, it stays the same. As we reflect our shape, this side stays the same, the angle stays the same. As we rotate, we're still staying the same. The only thing different is its location or orientation. So that's not as important as today or for today, but we need to remember that for future occurrences, especially later on in geometry when we talk about triangles. Oh, I'm missing the image. That's not good. That is not good. My bad. This needs to go all the way up here. Alright, I'm sorry about that. Okay, so we have this picture here. So we're going to start with translation. Translation is going to be our first transformation that we're going to talk about, our first rule that we can talk about. So if we focus on transformation, we see our translation. If we were to write this, if we were to create the words to represent this, if we were to turn this into English on how to describe this situation, you would say that it looks like the triangle ABC is moving, we're sliding, we're moving to the left by 5, and then we're moving up by 2. So it seems like each point on the triangle was moved to the left by 5 and up by 2. And so that would be the English way to represent this, the words to represent this. Now we wouldn't be able to write this in math notation. We need to be able to write a rule to represent this translation. And so if we see these coordinates down here, x, y, remember x is horizontal, y is vertical. As we change each of these points, we are changing the x. We're taking the x coordinates, say 1, -1, and we're sliding it over to this point over here. So that was a to a prime. A prime is -4, let's see, 1. So if we look, what happened as we went left 5 spaces is we subtracted 5 from our x coordinates. We took 5 away. As we changed and we went up 2 spaces, we added 2 from our original point to our new point. So when we talk about going left or right, we're either going to subtract by 5 or add by 5. We're going to go left 5 or right 5. As we went up 2, we added 2. If we were to go down 2, we would subtract 2. We want to recognize these words, recognize these rules, be able to know what they mean, determining for the situation. So let's see another one. So we have this rule right here. We need to write this rule right here. Sorry for that. So we have these two triangles, ABC in the blue and A prime, B prime, C prime in the red. We need to write what the rule is. Once again, I like to write the words and then write the rule from that. So if I were to write the words on what I see happening, I would say it moves, and it moves 2 spaces to the right. So I'm going to say right 2. And then I would say it seems to go up 3. So now that I have the words, now I know what's happening. I can write that into words, or I can write that into the transformation of what's actually occurring. And so if I were to create this rule and to write this rule, I would do xy. Once again, we always want to start with that xy. And then we need to turn it into what we're going to do, or turn it into our rule, turn it into our translation. So I always want to start with my left and right. My x comes first, then my y, so my horizontals come first. So I'm changing to the right by 2. I'm increasing in the x value by 2, so I'm going to add 2. And then I'm increasing in the y value by 3, so I'm going to add 3 to my y. And this would be our rule that we would write for our situation. X plus 2, y plus 3. And so now that we have a sort of a better standard on this situation, we want to be able to recognize when are we changing, how are these rules changing, how are we changing the situation, and be able to turn into the situation, or be able to recognize what's happening in each of these, and be able to change from the words to the rules. All right, so once again, take a moment, see if you can try this one on your own. Pause your video, see if you can do it. I'll give you time. All right, now we'll try it ourselves. Okay, so if we see, we have the black BC, and then we have B prime, C prime, and the yellow. So as we translate, sorry about that. Okay, sorry about that. A little technical difficulty with Mrs. Jalla. And now we are back. Okay, so we want to write this rule for this translation of BC to the image B prime, C prime. So if we look, once again, I just like to write that rule and then turn it into the notation. So I'm going to write left 5 because I am changing 1, 2, 3, 4, 5 spaces to the left. And then I'm going up 2. So I'm going to add 2 in the height. Once again, left is a negative direction for my x-axis. Y is my positive direction, or up is my positive direction for my y. So I can easily transform this into my notation as x minus 5, y plus 2. Awesome. And then we'll continue on. So now that we know how to write the rules and interpret the rules, we can start graphing these transformations. So we're given a shape and we need to start graphing what this looks like. So I have x plus 3, y minus 2. You might not need to do this, but I like to, just for the sake of convenience. I see that means write 3. Rather than going from words to numbers, I'm changing from numbers back to words. Down 2, or y minus 2, that's going to represent down 2. So now that I know my situation, what I need to do, I just need to take each point from this square, A, B, C, D. I need to move it right 3, down 2. So I'm going to take my A to start with, go over 1, 2, 3, 1, 2. B, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And you might need to do this for every point. You might not. It's really up to you and how confident you feel with yourself, or how well you're able to visualize it. So you might just need to get point A, and then you should be able to recognize where the others are. Or you might need to move every single piece. That's okay. That's up to you. And so, but that's really all we need to do for translation. Once you recognize that rule, once you recognize a pattern, you can just move every single piece or move one piece and then recognize where the rest goes, and you're awesome. All right. So similarly for this one, we have a pre-image. Or similarly for this one, we have this AB, but rather than being given the pre-image, we're given the image. So rather than be writing we're using the rule to figure out what this is, we're working backwards. We're given the wrong situation. So we're told that what happened was we were moved to the left 4 and then down 2 based off this rule. But we need to do the opposite now. So we're thinking, what happened? We're working backwards. So instead of going left, we're going to go to the right 4. And then instead of going down, we're going to go up 2. So to be able to figure out what the pre-image is, I'm going to take my A prime, I'm going to go to the right by 4, and I'm going to go up 2. I know that's going to be where I started. I'm going to go right from B, 4, and then up by 2. And that's where B started. And so that would be my pre-image of my object based off of my image. I'm just doing the opposite. But once again, turn those notation into words, or turn those words into notation, and translation is easy. So now we have a handle on translation. We're going to step it up a notch, and we're going to talk about reflections. So we're going to start reflecting something. Once again, transformations, big idea. Congruent parts of polygons map to congruent parts under reflection. So just like translation, reflection keeps things the same. Your angle is staying the same. Your side lines are staying the same. Everything's staying the same. The only thing changing is its location orientation. All right. when we talk about reflection, so we have triangle ABC, we're told we're reflecting across a line. Once again, reflection always deals with a line of, or an axis, or a line of reflection. So in this case, we have our y-axis. Now that y-axis, that represents my vertical axis. Once again, y is always a vertical line. That's going to be my up and down line. So that's the line I'm reflecting over. As I reflect, if I remember from last week, I remember that the distance from a point in that line of reflection is going to stay the same on both sides of my line. So A will be the same distance as A prime away from that line. If I count, A is only one space away from my line of reflection, my y-axis. So I need to go one space away in my opposite direction for A prime. B is 3 spaces away. So I will count 3 spaces away in my opposite direction. C is 1 space away, so C is 1 space away in the opposite direction. And that gives my A, B, C. And once again, you might be able to visualize this easy and just be able to recognize, oh, that's obviously where it goes. Or you might need to count. It's up to you. It's really how well you're good at, or how well you are at these visual, spatial, or seeing something and be able to spatially recreate it. And if you're not as good, that's okay. You just might need to count a little bit more. And that's perfectly fine. So now we're dealing with our x-axis. That's our horizontal line. So once again, we're going to do the same thing. So D is 2 spaces above my line. So D prime will be 2 spaces below. E is 1 space above. E prime will be 1 space below. Now here's the funny thing. F is on my line. It's 0 spaces away. So if I move 0 spaces away, I'm not moving at all. So F prime will actually stay at the same spot F is. And so it's possible to have your triangles overlapping each other. It's possible to have them on top of each other, or your transformations on top of each other. That doesn't change anything. That's okay. We just didn't have situations like that last week. And so that's D, E, F prime. So I'm actually going to skip this one, and I'll come back to it. We're going to go to this. So we have triangle ABC, and we're told to reflect it over the line y equals, or x equals -1. Now, x equals -1, we need to remember these lines back from Algebra 1 to be able to start to know what line I'm actually reflecting over. If we remember, we had a little mnemonic device to represent horizontal and vertical lines called Hoibucks. Now, what Hoibucks stood for is horizontal, zero slope, that O is a zero slope, and then y equals. This means horizontal lines have a 0 slope, they're flat, they don't increase or decrease, and they are y equals. So anytime you see something that's y equals, you know it'll be horizontal. But this situation, we had x equals, so that's going to be a vertical line. Vertical. We call that an undefined slope when it goes straight up and down. Once again, slope isn't as important in this situation for vertical and horizontals, but in case you want to remember it. And then it's always x equals. Whenever it's x equals, it's a vertical line, y equals is a horizontal line. So if we go back up here, we see x equals -1 is our situation we have. I need to find the -1 on my x-axis, so that will be right here. I know it's a vertical line because it's x equals. So I can go up and down, and that is my line of reflection. So all I need to do now, just like before, is count how many points away I am from that line of reflection. So A is 4 spaces away, so I go 4 spaces on the opposite direction. C is 1 space away, 1 space away. B is 4 spaces away, 4 spaces away. And that is my easy triangle to reflect. So you can take a moment, see if you can try B on your own. It's a little trickier. I'll give you a moment. Pause the video and do it. All right. So assuming you paused the video, you tried it. So if you saw y equals 4, when it's y equals, you should recognize that that's a horizontal line. But this horizontal line cuts through your triangle. But once again, reflection, you're just flipping to the opposite side of that line. So whether it's through your triangle or outside your triangle, you're still just flipping it. So E is 1 space above. So if I flipped it, I'm 1 space below. F is 1 space above. If I flip it, I'm 1 space below. G is 1 space below. So this is where it gets different. If I flip it, I'm actually going to the opposite side of above. So that's G prime. So my triangles are sort of interlaid on top of each other, and that's fine, once again. we're just spinning around that and reflecting around that y. So now that we've done these horizontal and vertical lines, let's talk about something that's a little bit harder when we start getting these diagonal lines. Diagonal line, I want this to disappear. Go away. Oh, so I have my diagonal line now. And it says remember perpendicular lines. Don't worry about that. For the moment, we'll talk about that when we get there. So these diagonal lines, this first one, this is the line y equals x. This second one, this is the line y equals negative x. And we can know this by looking at the slope. So the slope of my first line, I increase by 1, I go over 1. That's a rise of 1, a run of 1. Remember that slope goes right in front of that x. And because it's 1, I don't have to write it. This is coming from our y equals mx plus b, of course. No, stop. Y equals mx plus b. So that m, that number that goes in front of your x, that's your slope. Because it's 1, I don't have to write it. My b, that's my y-intercept. So if I see I'm crossing the y-axis at 0, so I would have plus 0 up here. But because I don't need that plus 0, it's not changing anything, I don't need to write something. So this is line y equals x. Similarly, I can do the same thing. I can look, and this is down or over 1, down 1, negative 1 over 1. And that gives me that negative 1 over 1 is that negative I see in front of that. Once again, my intercept is 0. So that's how I know these two equations are y equals x and y equals negative x. These are the most common equations I ever see reflective. Y equals x and y equals negative x. They are the ones that show up on your state test. They show up all the time. So it's important to be able to recognize them. They cross diagonals perfectly. You're always crossing those diagonals from corner to corner. Whenever you see that happening, you can know I can count by corners. So if I look at A, I'm half a block away, half a corner, half a diagonal away. So I can reflect half a diagonal away. Once again, same distance to get my A prime. B, I'm 1.5 diagonals away. So I'm going to reflect 1.5 diagonals away to get B prime. C, 1.5 diagonals. So I'm going to go 1.5 diagonals. Counting diagonals are a little bit harder than just counting straight lines. But just remember, you're going corner to corner, and then you should be fine. Same thing with FG. I always want to look opposite diagonal. So if I'm going up, I want to go down. So FG is going down, so I'm going to go up in a sense. So this is F is 1 diagonal away, so I want to go 1 diagonal in the opposite direction. G is 2 whole diagonals, so I'll go 2 whole diagonals in the opposite direction. And the reason this works is because these lines are perpendicular here. We'll talk about perpendicular lines later on in the future as we continue with more difficult reflections. But for right now, with these lines, as long as they're cutting diagonals, you can cut or you can count diagonals. There's actually also a sick little rule that we can use. So if you recognize you have y equals x or y equals negative x, rather than just counting like we did before, you can actually use this rule to help you. So if you have a point, the x is a, the y is b, you know your transformed point is actually going to be BA. So let's say I have A here from this situation. So A has a coordinates of, let's see, that is 1, 2. I know my transform A is just going to switch, so I know it's just going to be at 2, 1. And that's where this happens to be. Similarly, for y equals negative x, I do the same thing, except I'm changing it to a negative b and negative a. So if I have this point G right here at 3, 1, I can change this to negative 3, negative 1. And that's a quick little rule, but you have to be able to recognize it only works for those 2 situations. And if we don't have that situation, we need to learn something else. So I'm actually going to skip this first one because we can easily count diagonals and we know it's going to be like that. That's J, K, and you can practice that on your own time. Looking at this one, so we have the line y equals negative 1/2 x plus 3. So when we have these situations where we have negative 1/2 x, it's not just a straight diagonal. what we need to use is we need to use perpendicular slopes. So if we remember, perpendicular means the reciprocal slope. Perpendicular lines are reciprocals, just like parallel lines are the same, perpendicular are the opposite. So if I have 1/2, my perpendicular to this, I need to flip it upside down and then change the sign. So my sign right now is negative, I'm going to change it to a positive. So instead of going negative 1/2, I have positive 2/1. That's my perpendicular slope. So if I see this line is coming down at a negative 1/2 slope, I want to go up from my point A at a positive slope of 2/1. So that means I'm rising 2 and I'm running 1. If I see that took me a whole slope of 2/1 to reach the line, I then want to do a whole slope again. I want to do the exact same distance. So up 2/1, and that would be my reflection. But we'll pick this up later on.